Topic 13, trigonometry. Trigonometry is concerned with relationships between angles and sides of triangles. And understanding these relationships enables unknown angles and sides to be calculated without having to recourse to direct measurement. Applications include finding heights, distances, and angles. So the trigonometry we'll be looking at will be involving right angle triangles, as was Pythagoras' theorem. And just to remind us about Pythagoras' theorem, we have a right angle triangle. The side opposite the right angle triangle is called the hypotenuse. And that's still the case for trigonometry. The only extra thing that we'll have is either an angle that we're trying to find or an angle that we know. And the other two sides then are related to the angle. And this side that is opposite to the angle is called the opposite. He said mathematicians don't have any imagination. And the one next to it, or adjacent to the angle, other than the hypotenuse of course, is called the adjacent. Okay, so those are the three sides. And what we can do then is use trigonometry to find a side or an angle. And this all relies down to the fact that for any triangle that we have that was similar to this one where the angle was 30, so for all right angle triangles with an angle of 30 degrees, if we divide the opposite by the adjacent, or the opposite by the hypotenuse, or the adjacent by the hypotenuse, each and every single time they come up with the same answers. So the ratio of the three sides are fixed for every right angle triangle with an angle of 30, or any right angle triangle with an angle of 17 degrees, or whatever it is. So as we've already mentioned, the way in which we label a triangle is really important. We've talked about it briefly, but we'll spend a bit more time now. So angles we normally denote, or well, we do denote with capital letters. So the angle at the top of this triangle is angle A, and it's denoted with a capital A. This is capital C and capital B. Angle B at the bottom is 25, angle A is 65, and angle C here is 38. Angle C in the middle triangle is 90, and angle C in the middle triangle is also 90. And they're all denoted with capital letters. Sides opposite the given angle use the same letter but are in lowercase. So what we'd have is the base in this bottom triangle would be known as side A. The diagonal on the left would be side B, and the one opposite would be side C. Here we would have side A, side B, and side C. And then on the last one we've got side A, side B, and side C. So the angles and the sides are opposite to each other, and capital letters for angles and small letters for sides. Now, what we know, again, we've already mentioned this, the hypotenuse is the side opposite each right angle. So side A in the first triangle, or the line that connects B to C, is the hypotenuse. In the middle one, the line AB, the diagonal, is the hypotenuse because it's opposite to the right angle. And in the last one again, the diagonal is the hypotenuse. The side opposite the given angle is called the opposite. So line AB, or side C, is the opposite in the first one. AC is the opposite in the second one. And then the side opposite the angle in the third one is the opposite. And then we go to the adjacent, and we always label them in that order: the hypotenuse, the opposite, and then the adjacent. So the adjacent is next to the angle in each of these three examples. But it's always best to label them the hypotenuse first, then the opposite, and then the adjacent. Example, draw a triangle PQR where Q equals 90, R equals 27. What is the name of the sides PQ, PR, and QR? So it doesn't actually matter which way round we draw these triangles. So we could draw a right angle triangle in this direction, or we could draw it in this direction, or we could even draw it with the right angle up in the air. No matter which one we're using, the right angle is obvious, and we're going to label it each time with Q. And then the other sides are P and R. What we're told then is angle R is 27, so we can mark that in each time. And then what we want to do is label the sides. So what's the name? Not the aim, the name. So what we've got then, and it's same for each and every one of them, the side opposite the right angle is always PR, and that's the hypotenuse. That's the hypotenuse, hypotenuse, and the hypotenuse. Then we've got the other side is the opposite, and it's the one opposite to the right angle. Or not opposite the right angle, opposite the given angle. So opposite the given angle. So that is always PQ. So PQ is the opposite, which leaves the adjacent in each case as QR. So it doesn't matter which way we draw our triangle, the hypotenuse and the opposite and the adjacent will be fixed. Sine, cosine and tangent. So in all right angle triangles that are similar, so an angle that has, so all triangles that have an angle of 30 degrees. So if this is a right angle triangle with 30, and this is a right angle triangle with side 30, and this is a right angle triangle with side 30, then what we have is that these ratios, so these fractions will be fixed, they'll be exactly the same. So if we were to divide the opposite by the hypotenuse in each of the three green triangles, so if we measured them, if we drew them accurately and measured them, what we'd find is that the sine of the angle, so the opposite divided by the hypotenuse, is always fixed. And it's the same with the cosine and the tangent. Now these are specific to the ratios that are involved or the fractions that are involved. So the sine of the angle, the sine of angle A, is the opposite side, so the side opposite angle A divided by the hypotenuse. And what we have for that is, think about the S, the O and the H, and that's where our SO comes from. Cosine is always the adjacent divided by the hypotenuse. Again, cosine is adjacent over hypotenuse, and that'll give a fixed value for all set angles. And then the tangent is the ratio of the opposite over the adjacent. So tan is the opposite over the adjacent, which is where this TOA comes from. So the first term in this phrase, SOHCAHTOA, which is really central to trigonometry, represents either sine, cos, or tan. The second one always represents the top number in this fraction. And then the last number, the H, and the A in this case, always represents the bottom number of the fraction. So by labeling our sides, then we can choose which trig ratio we're going to use, either the sine, the cosine, or the tangent. And then we can use that to work out a length, a missing length, or a missing angle.